Hey, I just wanted to give you guys some more practice on adding and subtracting rational expressions before you have to do some independently. So I have three problems that I wanted to look at. So the first is 6 over 5x cubed y minus 1 over 2x squared y cubed. All right? So the first thing that we want to do whenever we add or subtract fractions is we want to find a common denominator. So I'm going to come over here and I'm going to write down that I have a 2, an x squared, and a y cubed. And I'm going to write down that I have a 5 and an x cubed and a y. And we're going to ask ourselves, what do we need to include to make sure that both denominators have what's necessary? So as we look at our coefficients here, this first fraction is going to, or this first denominator is going to require a 2. The second one is going to need a 5. Then I look at the third thing here in our list, and that's our variable x. All right, so how many are we going to need to make sure that both denominators are satisfied? All right. If you remember, we talked about this before, that there should be an x cubed. We need to take the one that requires the most. Right? This guy will be happy with just x squared, but this will not be happy with x squared. It needs an x cubed. Right? And then same thing here. If I've got a y cubed and a y, in order to make both of them happy, I have to have a y cubed. Right, so our LCD then is going to be 10 x cubed y cubed. All right, so I'm going to keep that in mind as I come back over here. And so I want to know, what do I have to multiply each of these fractions by in order to get that LCD of 10x cubed y cubed. All right, so what would I need to multiply this first fraction by? Well, it has the 5, but not the 2 that made that 10, so we're going to need to multiply it by a 2. It has all of the x cubed, but it only has a y. It needs a y cubed, so we're going to have to multiply by y squared. And then we do the same to the numerator, 2y squared also. All right, how about the second fraction? All right, well, this has the 2, but it needs a 10, so it needs to be multiplied by 5. It has an x squared, but it needs an x cubed, so we need another x. Then it has all three of the y's that are being here. Both have a y cubed, so we don't need to include any y's in here. So on top, I'm going to do the same thing, times 5x. So again, here's our original problem. And these are the things that we're multiplying by right here to make this have the same denominator. This is the second pair where we're matching them together so that they end up with the same denominator. All right, so let's write the denominator and numerator of each fraction now. All right, so when I multiply these two together, if I've done my job well, then I should end up with that LCD. So 5 times 2 is 10. There are no x's to multiply together, so this is x cubed, and then y squared times y gives me y cubed. All right, now let's do the top. So I've got 2y squared times 6. All right, that's going to give me 12y squared. And I come over here and I multiply these two together. Again, I'm really hopeful that it gets me the right denominator. 5 times 2 is 10. X squared times x is x cubed. And then we have that y cubed. In the numerator, that one's easy. 1 times 5x just gives us 5x. All right, in this step, again, soon you're not going to need to write all this, but I'm just going to show you just so that you remember all the steps. In the next steps, we're going to combine them into a single fraction with that common denominator that they already have. And we're going to combine the numerators. So this is going to be 12y squared minus 5x. Now we really lucked out with the second numerator because it's just a monomial. But in cases where the second numerator is a binomial we're subtracting, we have to make sure that we put parentheses around this and then distribute. Here we don't need to do that, so it's just going to be this as our final answer. Let me just erase that parentheses and I'll box it in. Things that we should be doing to make sure that it's our final answer is just check to see if we can factor the numerator at all and cancel out any common factors with the denominator. But we cannot do that in this case, so we are done. All right, second fraction then. Hold on, this looks like it got out of focus. Second fraction that we're going to look at, our second subtraction, is 1 over 6x minus 5x minus 3 over 4x. All right, so just as I was talking about up here, as we lucked out with just a monomial here, we're going to have to make sure we pay attention to this because this is not a monomial anymore, it's binomial. So we'll have to be very careful with our subtraction. All right, let's come over here and do our LCD. We've got 6x, which I'm going to write as 2 times 3 times x, and then 4x, which is 2 squared times x. And when I take the LCD, I'm going to go through and I'm going to look at all the factors, and I'm going to take the most of each of the ones that are common prime factors. So here of 2 and 2 squared, I'm going to take the larger, which is 2 squared. For the 3, I have no choice. I just have to take the 3, and we have this common x, so we're going to just bring that down. Right, when we multiply all this out, this is 4 times 3 is 12, and then times x, so our LCD is 12x. Okay, so we're going to come over here, and we're going to say, that's right, oh, actually, let me just do it right here again. We're just going to say, what do I need in each of these to get up to that common denominator, the LCD? All right, so in the first fraction, I need a 12x, I have a 6x, and so the only thing that's missing is a 2 that will make that 6 a 12. So I'm going to multiply top and bottom by 2. And then in the denominator here, I have a 4x, I need a 12x. What's missing is a 3, so I'm going to do top and bottom by 3. Again, here's our original problem. Here's what I had to multiply in order to get the common denominators. All right, so let's go through and convert each of these now to the common denominator. So top times top, we get 2. Bottom times bottom, we get 12x, which is what we were hoping for. I made that fraction really long, I don't know why. Minus, right, in the top, it's going to be 3 times 5x minus 3. There's a couple different ways you can do that. I'm just going to write it out front here as 3 times 5x minus 3. You could decide that you want to distribute it through first, which would be fine. If you did that, then you would end up here with a 15x minus 9. I'm just going to leave it like this for a second. All right, and then in the denominator, 4x times 3 is 12x. All right, now let me go through and start distributing here. Actually, I'll just write that extra step that we just talked about. So 2 minus 15x minus 9. All right, now this is the step where we need to be really careful because we have this. We're taking this fraction right here, we're subtracting a fraction that has a binomial numerator. So here's what I would like you to do. 2 minus parentheses 15x minus 9 over 12. And then in this step, we're going to distribute that negative through. And so we end up with 30x. Sorry, what the heck? We're going to end up with 2 minus 15x plus 9 over 12x. Getting a little sloppy here. All right, so now let's combine like terms in the numerator. I can't combine anything with this negative 15x, so I'm going to write them first. And then I have a 9 and a positive 9 and a positive 2, which is going to give me a positive 11 over 12x. And then I'm going to look at the numerator to see, can I factor this? Right? Is there anything I can take out that could potentially simplify with the bottom? Right? Hopefully you're saying no. 11 is prime, so the only common factor they could share would be 11, but 15 doesn't have that, so there's nothing I can do. So that would be our final answer. Again, as you work on these more, you're going to get to this step and you're going to say, I don't need to write that, I can just write this. And then you're going to say, I don't need to write this separate step, I can just combine them into one. So know that I'm just doing all of these steps right here because we're just at our beginnings here. Eventually we'll start to condense them into fewer steps. Okay, one more. Okay, I have one more problem that I would like to look at, and that is x minus 1 over x minus 2 minus x squared plus 4x minus 4 over x squared plus 4x minus 12. All right, so note the differences between the last two problems we did and this. In our first two problems, we just had monomial denominators, and here we have a binomial denominator and a trinomial denominator. If you think back to when we did problems like this, when we were solving rational equations, not simplifying rational equations or adding or subtracting, simplifying rational expressions or adding and subtracting rational expressions, we needed to get the prime factorization of these first in order to know what the LCD was going to be. So our first step here is going to be to rewrite this in its prime factored form. So then you need to think, well, how am I going to factor that? Right, so hopefully you're saying that you're going to factor this using easy general trinomial factoring. So we're looking for two things that multiply to 12, that subtract to 4, and the larger is going to be positive. So this is going to be an x plus 6 and an x minus 2. All right, so then when we go to find the LCD over here, we're going to write all the factors that we have. Our first fraction has a factor of x minus 2 in the denominator. Second one has x minus 2 and x plus 6. So you should be able to see that we need an x minus 2. Both of the fractions need that, and the second one needs that x plus 6. All right, so as I've done before, I'm going to come over here and I'm going to say what is each fraction missing. And then we're going to make sure that we multiply top and bottom by it. So this first fraction has the x minus 2, but it's missing this x plus 6. I'm going to put parentheses around here just so that you remember that you need to FOIL them out when we start working. And then again, the numerator needs to get that x plus 6. All right, how about the second fraction? Well, you should notice that they both have, or that this one has whatever the LCD is here, right here. So we don't need any extra stuff here. So you could just indicate that with a times 1 over 1, or you could just say, I don't really need to write anything. Okay, so I'm going to rewrite these. All right, so x plus 6, x minus 2. This is an x squared plus 4x minus 4. And when I rewrite the second fraction, I'm going to multiply the top out. All right, so I end up with an x squared minus x plus 6x minus 6. All right, now I'm going to do two things when I do my next step. I'm going to combine this into a single fraction, so a single denominator, and then I'm also going to combine like terms here. So we end up with x squared plus 5x minus 6. I'm still not going to do anything with this one, but I am going to put this second numerator in parentheses because I need to subtract all of it, not just the x squared, but I need to do minus the x squared, minus the 4x, and minus the negative 4. So I'm going to do that in the next step. For right now, let me just write it like that. All right, let's go ahead and do that in the next step here. So I'm going to distribute that negative 1 through x squared plus 5x minus 6. Now we're going to get minus x squared minus 4x plus 4. And that's all over the common denominator. All right, again, we need to combine like terms here. So I'm going to have that x squared minus the x squared. Those will cancel out. I've got a 5x minus a 4x. That's just going to give me an x. And then I've got a negative 6 and a positive 4. That will give me a negative 2 over x plus 6, x minus 2. All right, now in this stage I would say, well, can I factor the numerator? If I can, let me do that. There is nothing I can factor in the numerator. This is a prime factor. And then I would say, let me look to see if there are any factors in common in the numerator and denominator, just like we did when we simplified rational expressions. And I can see, yes, right here, I have an x minus 2 and an x minus 2. Again, remember, these are package deals, so they have to look identical. So they do. So I'm going to cancel them out. In the numerator, there's always an implied 1 up there, so it's not that there's 0 left up there, it's just that implied 1 that we're going to make explicit. And then in the denominator, x plus 6. And that is our final answer. All right. Hope that was helpful. If you have any questions, be sure to ask.